Good morning.
Good morning.
Finally.
Good morning.
I'm happy to be here in Yukihiro, Taiwan, and I'd love to see a lot of new faces here. And okay, could you raise your hand if you have seen my face for the first time? Okay, thank you. Nice to meet you. Okay, this is RubyConf Taiwan. That means that we talk about Ruby, right? And you came here to RubyConf Taiwan to talk about Ruby, and because Ruby is good. Ruby is good because it's productive. It's make you productive, and the Ruby language, the program written in Ruby is flexible, and the most importantly, the programming in Ruby is fun. But at the same time, Ruby has some bad things. And then sometimes Ruby is dead. But Ruby is less popular. Okay, let's see the numbers. In the theory index, which is the popularity ranking of the programming language, and it's summarized every month. And this month of the July 2019, it's 11th out of 150 languages. Less popular. Okay, we have the popularity ranking of the programming language. It's named the Red Mark Index. Okay, in Red Mark Index, Ruby is the 8th in the 20 languages.
Okay.
Less popular. Okay, in most of the cases, Ruby is good enough. Ruby is used for the big sites like GitHub is written in Ruby, Airbnb is written in Ruby, Instacart uses Ruby, and CookPath is written in Ruby. So that for most of the cases, Ruby is fast enough. But if you're a startup company and if you're implementing your services and you're expecting your service will grow like GitHub, okay. I don't see any problem. Even if you face the problem, so that I don't think it's our fault. It's not for us. Ruby is fast enough for most of the cases. And then if you reach the limit, maybe the performance is slow, or maybe the cost of the cloud is too expensive. But I think it's okay because you pass the very critical phases in your service. Let me tell you about the Twitter story. Twitter started in 2007, I think, 2007-ish. And then at the moment Twitter came out of the world, so that everyone thought that Twitter was crazy because you can write as long as you want in any blog service like bloggers and WordPress, but Twitter limited its message in 140 characters. And then one of the founders of the Twitter came to the VC and explained about their services. Okay, I'm going to social networking service whose messages are limited in 140 characters. And they refused to invest because it appeared to be silly. But years has passed, so that they introduced, the retweet, DM, or maybe the messaging, or the other many things. And Twitter became very useful. And it's quite popular right now, more than 10 years later. But a few years has passed since the Twitter started. that they had some kind of issues of the performance of Ruby language. The very early version of Twitter was totally implemented in Ruby on Rails. But consider that the Twitter system is now very suitable for the Ruby on Rails product application frame, the architecture. So they try to migrate to the new architecture, the messaging architecture. They implemented the messaging framework named Kafka, and it's written in Scala. But the point is that at the very early stage of Twitter, no one knows what Twitter should be, and they try to many things, like introducing Twitter, and then they abandoned some ideas. They pivoted several times, but after that, they define what Twitter was, and then they get virality, and they face some kind of traffic problem, performance problem, and then at that time, many people, including the VC, invested. They knew Twitter is the one. So then they started investing, they started making business and making money, so that, okay, now we can use this money to re-implement everything after we defined what Twitter was. So that I believe that starting in Ruby is pretty crucial for Twitter service. And they implemented their service in Ruby 1.8, which was very, very slow compared to the current Ruby. And then Ruby 1.9 and later is much faster. So that if they try to migrate to the Ruby 2, the break-even point is even farther. Okay, and the limit is moving. And in the Ruby 2 era, we have improved the performance like this. Okay, slightly, each version, the performance improved and slightly. Okay, Ruby 2.3.4 and 2.4 up to 2.6. The performance is slightly improving, keeping improving. Okay, let's face it, Ruby is not perfect. We have some issues. But we have issues in performance, so compared to some languages like, say, whatever, Go, Rust, the JVM language like Scala, Clojure, so we might slower, and the Ruby language does not handle the multi-core machines. And then we have some issues when we're working on in the bigger team or bigger project. So that but that means okay. The performance we have for when you are providing the web services using Ruby, due to the performance, that you might need to pay more for the nodes in the clouds. But so the performance improvement directly results in the cost. And then in these days, the computers has multi-cores. So using multi-core is pretty much important. But current Ruby VM only uses one core at a time. But in web architecture, it is quite easy to use a multi-core because of the web architecture is easy to use the cores because of each request can be divided into processes, so that the operating OS can use the multi-core anyway. And then the team gets bigger, and the software code base get bigger. You might have the issue of the API changes and type checking things. So that the flexibility of Ruby can be drawback in this region. So but that means we can improve these issues. We have the room to improve. So open source community cannot stop. So if we stop improving, so you got bored, so you might change to the different language. So we cannot stop. We have to keep moving. So we keep improvement. So and even further in Ruby 3. Okay, Ruby 3 is the future. But how can we improve? The big improvement in Ruby 3 will be classified into three. One is the performance, the second is the concurrency, the third is static analysis. Let me tell you about the static analysis first. In these days, recent languages like Go, Swift, Rust, or whatever, or even TypeScript, is statically typed. But recently, the statically typed programming language is pretty much popular. Yeah, I admit. And then, as the project grows, the test becomes a burden. Test increases size, and then test execution takes more time. And the test is not dry, don't repeat yourself. It's kind of against a dry principle because you write a test, you write the program to process your data or something. Okay. You write program to work, and then you write tests to make sure. It's kind of redundant. But if it's possible, I don't want to write tests, but the humankind have not invented the way to ensure the correctness of the software without writing tests, so that we write tests anyway. But we do write tests anyway, but want to be more productive, so that we want to reduce the amount of tests. So the other languages try to reduce the burden of tests by type hinting, or type annotation, or TypeScript. So by those languages, so that it's not 100% checked, but the PHP, Python, JavaScript as a dynamic programming language, but at the same time adding some kind of type information to checks the type inconsistency the more at the compile time, so that we do not worry about the type errors in our tests. So what should we do? The Ruby community should do. But adding type annotation like other languages, like PHP or Python? No. I hate type annotation. Because it's not dry. So our Ruby program runs anyway with a type annotation. So that if we add a type annotation to the language, it's redundant, right? So that we want our type hinting, or not type annotation, declaration, because it's not needed. So we have the plan, so that we are going to introduce the static type checking components to the language in Ruby 3. The first is the type definition syntax. The second is the type definition support library in this syntax. And the third one is the type profiler. The fourth one is the static type checker. Type definition syntax is Matsumoto is working for this work, and I think he must be here, there. And he's in charge of this project. This is kind of compromise. So that if our compilers are smart enough, so that the compiler can infer or guess the static types of your software. But we cannot reach that far. So that we have to define the type information in a separated file. It describes the argument type, return value type, and the class module, and the general types, and even interfaces. In the form of the syntax like this. The class foo has the foo method and the 2s method, and then returns string or something like that. And then we are going to provide a tool to parse out this obvious file. And this is a prototype. So once this syntax is fixed, we are going to provide a type definition for libraries, standard libraries and the gems, so that we can have the type information of the existing libraries. And then we are going to add the type profiler as a tool. The Yusuke Endo is working on it. This is the key component of the static analysis of Ruby language. It uses the techniques called abstract interpretation, AI for short. Okay, let's see. This is the silly example, and this is a small Ruby program. Again, define a method and the calls method. And the abstract interpretation interpret the execution of create a call graph of the software. So we call the method foo with the argument of the integer 15. Then in the definition of the foo, we can tell that the foo method is called with integer argument. So the a must be integer, and the integer has a class method. So the a plus 2 is legal. Okay, but if we try to add the string 2 or something, string to the argument a, so that we don't have the method to add the integer and the string, so that it must be error. That kind of things. The type profiler works the collect type information like this, and then detect type conflict of typing from the type information. Then you can create the obvious file. So that this foo method returns takes integer and returns integer, or something like that. So the type profiler can work as a level 1 type checker. So that this is not 100% accurate, but it detects the casual errors, type errors in the Ruby program without execution, without tests. And then you can generate the obvious file automatically of your software. And then, as I said, this is not 100% accurate, but you can refine the generated obvious file, type description information. You can refine generated the files. And we may also provide the YARD from the YARD to obvious converter, so that when you write down the YARD document with the type information, so that you can generate the type description from YARD documentation. This is planned but not yet worked yet. Okay, the last component is static type checker. So when you get the type description information from all your software, from the libraries, from the gems, and the generated obvious type description from the type profiler, you can check types of software. We have two candidates This is an independent project. One is the solver from the square, stripe, stripe. And then the second one is straight. These static type checker use the object type definitions. And then those two have different characteristics. The first solver, it is recently open sourced. That you can get it from here. And a solver is written in C++, and it is quite fast. And its type check is mostly nominal. And it supports the type annotation DSL, which is different from the RDS file. But RDS support is coming. So the we core team is working with the solver team, so that they promised that they will support our RDS definition. The steep is written in Sotaro there, and it's written in Ruby, and it uses the structural typing. And since it's written in Ruby, it's more flexible and easy to experiment. I believe these two would have the healthy competition of the static type checker for Ruby 3. So imagine we have these the static type components. What will happen? So your ordinary Ruby programs will be statically type checked without any type annotation in your Ruby programs. And then if you refine type definition files, you will have better type checking. Wouldn't that be cool? And we are working on it, and the result is pretty promising, at least from my point of view. Okay, so Ruby 3 will be released next year. Okay, the plan is the December 2020, so that year something later. And we're working on it. We have prototypes, and we have one more year. But we are trying. This is type checking. The performance. We are trying to improve the performance for a long time, and no language can be fast enough. Someone complains even the fastest language. And as I told you before, the Ruby 3 improved the performance, and like this graph. But even further in Ruby 3, we need more performance, like a big service. But the most importantly, the people, especially managers, feel anxiety about the performance of Ruby. So many people claim that Ruby is slow. No, Ruby is fast enough, but it's kind of difficult to persuade others, like executive managers, so that we need to improve the performance to persuade them. So that we need to address bottlenecks. We have the bottlenecks like memory, CPU, and I/O. And the memory is the first bottleneck. Maybe it's contrary to your expectation, but memory is the big bottleneck for the web services, especially big web services. But we have improved the memory management, which component is the garbage collector. So in the past, we introduced the generational garbage collector, which reduced the throughput of the garbage collector, and we added the incremental garbage collector in Ruby 2.2 to improve the latency of the garbage collector. We introduced the transient heap memory management, which reduced the amount of the pages allocated from the operating system. And we are going to introduce the object compaction in Ruby 2.7, which should be released in this year. Then, which reduce the total amount of memory consumption, so that we are constantly improving the garbage collector, so that we improved a lot of the memory bottleneck. Compared to in the past, some big service use the technique like OOBGC, which stands for the out of bound garbage collector. For example, like big services like Cookbot or GitHub, they kick the garbage collector explicitly, between the requests to avoid the garbage collection in the middle of the request processing. But since we introduced these kind of the techniques in the garbage collector, that kind of OOBGC is no longer needed in any services. So, CPU bottleneck. Yes, some bottlenecks resides in the CPU. So we introduced the JIT, stands for the just-in-time compiler. So in Ruby 2.6 released last year, introduced the MJIT, which is our JIT compiler. So for CPU-intensive tasks. So our CPU-intensive benchmark is RubyConf, which is the Nintendo Entertainment System emulator. So it runs games. And then, in benchmark mode, RubyConf runs its game as fast as possible, and we count the frame per second. And then the RubyConf in Ruby 2.0 runs in the 18 frame per second. It's too slow to play. 18 frame per second. It should be 60 frame per second to play the original game. But Ruby 2.6 runs 2.8 times faster than Ruby 2.0, so it's almost 60 frames per second. So it's quite nice. And Ruby 2.7 runs even faster. Actually, I confess that JRuby runs 8. How many? Charles, do you remember how many frames? 78. Okay, JRuby runs even faster. And Truffle Ruby runs 120 frames per second. But we are working on it. The JVM is implemented by the very smart people from Oracle and IBM, with the tons of PhDs and stuff. We are teeny teams, so we are working on it. And Ruby 2.7 even faster. And by using JIT for Rails apps runs slower because the most of the Rails application, the bottleneck resides in the memory, or so that improving the CPU burden is now very helpful for improving the Rails performance. In addition, we have too many methods. The Rails is a huge framework, so that it has so many methods. So that means so many methods to compile. The compile overhead is now really cannot be ignored. And then most Rails application is I/O intensive, so that we need to improve the I/O performance before the CPU performance. But there's a way to improve that kind of things. So that Vladimir Makarov, who originally created MJIT, who is working for Red Hat and in charge of the GCC optimization, he works to improve the performance of the GCC in his day job, and he improves the Ruby performance in his side job. He's quite smart. And he's working on the different layer of the JIT compiler, and named Mio. Mio is the lightweight JIT compiler, and it accomplished 80% of the performance of the MJIT with very few overhead, maybe 10 1/10 or even less overhead, compiling overhead with 80 to 90% of the performance. So after we introduced the mill, we could have the 3-tier JIT. Most of the methods run in VM, but some hotspot is compiled by the mill, and some very hotspot is compiled with using the MJIT, which is the very optimized JIT compiler. But JIT may not be used for web application anyway, because it's not a bottleneck. But the JIT would be useful for research computing, like a number crunching things. So that maybe in the future, so that Ruby is fast enough to use in research computing. If we keep moving forward, anything could happen. Like the language popularity goes up and down. Like 15 years ago, in the scripting world, Pro was the king. And the Ruby is chasing it. But a few years later, the web came, and the Ruby on Rails got huge popularity, and the Ruby was the king, at least in the web domain. But right now, recently, so people are focusing on the non-web field, like machine learning, AI things, and they are admiring the Python. But anything could happen. If we keep moving forward, maybe the Ruby is used outside web. The Ruby gained more popularity in the region. So the other way to improve the performance is concurrency. Concurrency is hard. I wrote it down in threads. Remember, when I add the thread to the language, there's one CPU per computer. So that I consider threads as the construct of building the concurrent algorithm, like a producer-consumer model or something like that. But it was not really for the performance. But these days, we have tons of CPU in the computer, like a 64-core machine on the cloud or something like that. But that time, the concurrency is pretty important. But at the same time, using threads correctly is pretty much difficult. It's hard to use correctly and how to use efficiently, how to debug. But the most thread programs are non-deterministic. So that you have error, but the next time you test, you might not see the error. It's timing. So you may see the bug with the 1 out of 100 or even thousands. That's a tragedy. So I think we need better abstraction to utilize the cores in the machine. So we have several approaches. So one is the guild, the second is the auto fiber. So the guilds for the CPU bottleneck. The auto fiber is for IO bottlenecks. And they are easy to use, easy to debug, easy to perform. In language like Go or Elixir, it is the single entity. Like Go has Go routine, and then Go routine can be used for the CPU performance and then I/O performance as well. And Elixir has the processes. Then the programmer can use processes for the CPU intensive tasks and I/O intensive tasks. But the Ruby is now really designed as a concurrent programming language from the scratch, so that we have to make some kind of a compromise. This compromise can be formed as which one? Oh, this one. The guilds and not fiber. And I don't really satisfied with the name Gills and not Fiber, so that we have to come up with a better name. So that is a very huge problem. Names. So that, yeah, the most difficult things in the computer science is the naming things and the cache invalidation. And then, originally, the guilds was named guilds because of the membership. Each object belongs to the guilds, and then the object can be migrated to another guild. But that was the original plan. But it found out the migration is heavier than copying. So that the migration does not really useful in the guild programming. So that we no longer, the membership is no longer useful in the mind model. So the name guilds is not really suitable with the good names. In addition, we have some complaint from the gaming industry. Some companies they're providing net games and use the class, the model class named guild. That's a huge problem. Okay. I'm proposing the name isolate, which isolates object from the outside. But the Koichi, who is in charge of this guild stuff, is not really satisfied with the name. So that, okay, if you have any ideas, feel free to tell me about that. Okay, the Outfibers. Outfiber is the original name in the proposal for the I/O intensive task, but the name fiber deeply assumes the coroutine, which is the context switching is explicit. But Outfiber switch context in the I/O operation implicitly, so that it's not really fibers. So there are some complaints about this, and maybe we should just change the thread behavior, or maybe name it threadlet or something like that. So that your opinion are welcome. So that these improvements are inspired by functional programming languages, and then static typing and then concurrency models, and even more. Recently, we introduced the number block parameters from languages like Scala, Gojira, and Ruby, like this. Instead of declaring the variable in the bars, so that we can use the app1 as the first argument of the block. Yeah, I know we have controversial things. But we have other options, like naming it, like grooving and coupling. Or maybe we can use the %1, %0, %1, %2, whatever. Or just ignore the last art sign. I just forgot to remove that. Okay, we are going to add this number parameter syntax in any way. It only takes one argument. That's a big difference. And then, And yeah, the current idea has multiple arguments, like up one, up two, if they take the two parameters. Well, pattern matching. We recently introduced the pattern matching in the master. It's not the regular expression pattern matching, but functional programming pattern matching. This is an example. You parse the JSON, you find an entity named Alice, whose children was named Bob, and takes the query his age. If you write down this pattern matching in the traditional way, it goes like this. the person's name is Alice, and then children was the person's children, and it was when the children has only one child, and the first children's name is Bob. They print the age of Bob or something like that. You compare this and that, which is simpler and then more straightforward. I think this one, right? Yeah. I admit in is a little bit awkward for the pattern matching, but yeah, we are lacking the number of the reserved words, so that yeah, we can help it. But we can make compromise for this conciseness of the description. Chaining operator. It's from the F7 elixir, like this. Instead of this. Almost same. That's controversial because of some claims it's against their expectations. The pipeline operator was originally introduced to the F# and the other family languages. So the pipeline operator defines like this. Then the behavior of the pipeline operator in F# is the other primary argument, which is the most important argument of the function at the end of the arguments. Because F# has carrying, so the most important argument comes last. For example, the map function takes its sequence or array at the end of their arguments, and the function comes first. The pipeline operator in Elixir is defined as a macro, and it as the primary arguments as the first argument of the function. So that in Elixir, map function takes sequences as the first argument of the function calls, then the function comes the last. So that the concept of the pipeline operator is the primary arguments the call, and then the position of the primary argument varies in the language and its library. Then, since ML-like languages, the primary arguments comes at the last, and then since Elixir, the primary argument comes the first, so that they put their primary argument in the position according to their language, culture, and the definition. That we are going to, if we add the primary argument to the Ruby, so that it should add the primary argument to the call. In Ruby and its standard library, primary argument comes as the receiver. So the adding the argument as the receiver is a pretty natural for Ruby. Skip. So I'm not 100% confident. But not that it's before 2.7. So we have months before the release. So it's okay to cancel the change. But I have to experiment because if we haven't introduced it into the master, no one noticed that. So that no discussion, and then after release, so that everyone's surprised, and everyone complains. So many people complain, but it was too late because some people start using it in the real world production code. We cannot remove that after the release. So that adding that right now is a very important. Okay, the term pipeline is confusing. Let's say chain operator. An operator may be changed from pipeline to three arrows or something like that, or give up the idea altogether. at least we get some ideas from the discussions. Like, okay, we have to allow comments in method chains like this. This is invalid in the current Ruby, at least the 2.6. We cannot make the comments in the method chain, in multi-line method chain. But now we allowed it. Okay. This alone is pretty big benefit for the language. And then we realize the requirement for the right assignment. Okay. Our mind goes like, okay, the sequence of the 1 to 100, then map, sort, reverse, take 5. Then, if you want to assign the result to the variable, in current Ruby, you have to go back to the top, then assignment. It's against the sequence of our mind. So that if we have the right assignment, we can write that, okay, 100 map, sort, reverse, take 5, then top 5. Yeah. Or then enhancement. Okay. Similar things. Okay. If you want to print the result, print result from the sequence, you have to put the put method or print method at the top of the method chain. But it's against me. But if we enhance the then method, which is introduced in 2.6, so you can print the result in the bottom of the method chain. This discussion alone can inspire this improvement to the language. This is pretty important. So that if we abandon the idea, if we give up the idea of the chain operator or Python operator, so that once we get these kind of the ideas from the discussion, this is pretty much more worthy for me. So we need to survive. We need to survive because many of us making living out of Ruby, so that we have to keep sustain our lives, especially my life. And okay, probably it's okay for you to move on to the other language in your next project, but I have nothing else. And we co-commuters, we have some full-time co-commuters hired by companies to maintain Ruby, to improve Ruby. And if Ruby won't survive, it will ruin our lives. So we have to survive. I have to survive. Most importantly, to provide benefit to Ruby users. And and we will keep moving forward because Ruby is good enough, but then we have rooms to improve, so that we have to keep moving forward to sustain Ruby, to grow the success from Ruby, and then we want to support your business. We want to support your lives and earnings. And especially the Ruby community can be better in productivity and effectiveness and joy. And then I don't think it's the whole responsibility of the core team or even me, but it's the community work. That we can the community can improve the Ruby and then to make us happy and to make the world a better place. So that is the community work. Thank you for the community. The Ruby, I started Ruby alone, 1993, which is 26 years ago. Whoa, it's old. 26 years ago, it was my hobby project. I started alone. But now we have more than 100 co-contributors, and more than a million Ruby users. And it's all over. The Ruby users lives all over the world, in Taiwan, Japan, United States, and then in Europe. Actually, at this moment, we have the RubyConf Kenya there in Africa, Nairobi. We have a lot of conferences. We have a lot of users, and they are using Ruby to sustain their lives and to make world a better place. This is community effort. Thank you for involving Ruby, and thank you for helping us. Thank you for working with us, and thank you for being here. Thank you.
ありがとうございます。I can't believe everybody got a lot of questions for Matsu-san. But before we start the QA section, let's welcome our sponsor, Pig Lodge, Russell. Matsu-san will be back on the stage in 5 minutes. By the way, there's no food and drinks allowed in this venue.
There wasn't a adapter here before? There was an adapter for the USB-C. Thank you very much.
Everyone feeling okay? Very happy to hear and to see Matsu-san, right? Really? Okay, now we're talking.
Not yet.
Sorry, Mats. Yeah. Hi, hello everyone. Good morning. Yeah, my name is Russell. I'm with Quick Collage, and we're very happy and very proud to be sponsoring Ruby Conference 2019. So thank you so much for having us here. I know you want to ask questions to Mats, and so do I. So I promise to keep this very brief. So it's just a very short, I guess, commercial break. Okay, so I wanted to say thank you to the organizers and to everyone who's here. And I wanted to also say thank you. I think some people came out last night to a party we had at our office. Was anyone there? Yeah, good to see you. Maybe some people are still sleeping it off, and they'll come later. So I want to tell you a little bit about Pic Collage, just real quick. So what we do is we help people create and celebrate. So this is a photo collage of some photos from last night. So we had some food, some games, some music, and most importantly, we had a lot of wonderful people, including a lot of you there, and it made it a great success. And so this photo collage was made with our most popular app, which is Pic Collage. So Pic Collage has 200 million downloads now and 15 million active monthly users. And what we want to do with it is we want to be able to help people create and celebrate by combining friendly design. So we try to make it super easy to use. We want to inspire people, help people create new things. And we combine that with what we like to call serious technology. So here's our CTO, and he's working on some, I think this was the day we were talking about observables of observables. So yeah. Part of the serious technology we use is Ruby. We've been using Ruby since the beginning. Our backend is written in Ruby, and I wanted to get some stats. So yeah, so here's some statistics that we looked up this morning. So It looks like we've written 19,000 lines of code. Is that a good statistic or bad? I don't know. So you tell me. So on average, we get about 30,000 requests a minute to our API, which is written in Ruby, mostly on Rails. Some of it's in Sinatra. We have about an average 90 millisecond response time, and what I think is a very good error rate. They assure me this is all bad requests. It's not their fault. So you can see the sticker here. With Ruby, the sky is not the limit, but an object, like everything else. So this sticker, you can come to our booth. We have some stickers here, and thank you, Jenny, if you're in the hall. She's one of our server developers who works in Ruby, and she made this wonderful joke for you. Okay, so we want to work on like inventing the future of how people create. And some interesting problems that we're working on right now are machine learning and computer vision. So we're trying to figure out how can people have cool effects to work on the photos that they're working with, right? So here you have an example of going from an idea to something we're actually able to do, combining ideas like segmentation, photo effects, all these different things. Another cool problem we're working on is automatic video editing. So we have another app called Vibes you guys can check out. Let's see if this plays. So on the right is an automatically created video. Sorry for the formatting, this should be on the phone, but when you upload it to Google Drive, it puts it in the YouTube format. This was a workshop we did that we learned how to make keyboards, which was really, really fun. So I'll talk a bit more about that later. And I wanted to just mention briefly about what we value at Pic Collage as well. So one of our biggest values is always be learning. So I just mentioned that keyboard workshop, right? We decided, hey, let's do this, let's learn how to make this. This is pretty fun. Some other workshops we do, we had a presentation on static type checking in Ruby from Maso, who's here today. Hi, Maso. And we had functional programming workshops, reactive programming workshops. We had workshops on Swift UI for our iOS developers, and this is all just within the last month. So you can see we really love learning as a development team, and we spend a lot of time doing that together. Another value we have is live well, work well. So you guys have probably heard like work hard, play hard is what a lot of people say, but we like to think of it this way. So I flip it around, life comes first, and you should do it well, not just hard. So our office used to be a gym, so we just invite people to come teach classes there. As some of you saw last night. So we offer we have this TRX class on Friday or yoga or anything twice a week. And then we also try to spend a lot of time together out on lunch. So the company, we all go out to lunch every day, and that's something the company helps provide. So that's a little bit about our culture. So the reason I wanted to talk to you guys is to let you know that we are hiring. So we are looking for people to join our team, and I think that there's a lot of amazing people here today. So if you're looking to find out more about us, just to chat, or if you're looking for opportunity for maybe future work, please come talk to us. We have a booth outside, so this is Yenting and Jenny. They both are on the server team. So people will be at this booth, you can talk to them. Come get those cool stickers with the joke on it. We're hiring server developers, web developers, Android developers. Also, if you're a software engineer of any kind, we'd love to just chat with you. Or if you work in another department, like you work on product or design or something, please come talk to us as well. You can also check out our website, piccollage.com/jobs. And with that, I want to say thank you, and I will hand it back so we can get to the QA. Thank you very much.
Thank you, Russell. And now, drum roll. Matsu-san, you ready?
Yep.
Thank you so much. Now Q&A session. So do you have any questions from the audience? Don't be shy, raise your hand and ask a question. Really? No question? Once in a lifetime.
Yes.
Oh, okay.
I have a question about life science assignment.
Right assignment, yes.
So can we write science assignment so during the method chain or last one?
No, just last one.
Why can we write in the middle? Why can we write in the during method chain?
Oh,
You can use that the right hand assignment in the middle. using the top method.
Yeah, that's
But once you use the right-hand assignment,
mm-hmm.
but the method chain has been finished, so that you cannot have the way to chain the rest of the method chain after the assignment. The only way is the top method. You can call the top method, and then you assign the value, the current value, into the somewhere using the left or right assignment.
I see.
Any more questions? Okay. Actually, you can use the intercom next to you.
Yes.
Just press the button there, and then you can ask a question directly. But please raise your hand first.
Okay. Do you have an idea for the Ruby 4 or Ruby 5 after releasing Ruby 3?
Our strategy is one at a time. I'm not thinking about the Ruby 4 before releasing Ruby 3, but the big idea is that after Ruby 3, I think we are going to work on the supporting tools, like the tools like RubyConf or the even smarter static type checking tools, or Ruby formatters, or maybe some kind of analysis tool like a language server to support the IDEs and editors or something like that. So recently we had the ASD disclosure in the Ruby 2.6. That is the one preparation for the next phase after the Ruby 3.
Thank you.
Great. Do we have any more questions?
Yes, Samuel.
Some features that were going to be removed or deprecated for, some features that were planned for Ruby 3.0, like the frozen string literals, so it's been cancelled. Do you think we'll revisit that in the future?
Well, currently, the keeping the compatibility is the big things, because once we break compatibility, so many out of the millions of Ruby programs will be crashed. So that for Ruby 3, the keeping compatibility is quite important. So that we cancel something which could break the existing software. But at the same time, after Ruby 3, when we use the migration tools or the supporting tools like the RubyConf rules or something, so that we are much easier to make a deprecation or some kind of the backward incompatible change. Once you run the migration tools, so you can migrate to the newer version, so that you don't have to worry about the compatibility less.
Right. That makes a lot of sense. Thank you.
Yeah.
I would like to know more about how is your development process for the whole team? What's your teamwork? How do you discuss, or is it mainly your direction for those thoughts, or those direction, or is it collaborative things? How do you work with the different contributors all over the world?
The final decision was made by myself alone, but as the dictator. But I am not the expert of everything, so I have to consult about the trade-offs and the background of the proposals and the ideas, so that I have to talk with some people, and then most of them the co-commuters, but not really limited. But maybe I have some information from the discussion on our red mine, and if we don't understand I don't understand the description of the trade-offs, so that I have to consult with some co-commuters. And then from those information out of this from the community, so I have to make the decision.
Hello.
Hey.
Yeah, I have two questions. So the first question is about the new comparison model, GILS and the auto fiber,
Yeah.
because I think I have heard these two new comparison model for probably 2 years or 3 years, and so I'm curious about what's the progress of these two new comparison model. Is it planned to release in Ruby 3 or just before Ruby 3? And the second question is about the new type checking, and because for the SOBAT and they have wrong
Okay, let me ask one by one. Let me answer one by one. The first question is the guild and the auto fiber. For auto fiber, the implementation is there, so that it's originally from the pull request from the community. So the pull request is there. It is working, but probably we have to improve and improve the performance, and we have to debug something. Well, I think it still have the bugs, so that we have to fix them. So the auto fiber is there, and I'm not sure that because the blocking, the biggest blocking for the auto fiber is the name. So once we get the names, it can be introduced into the root to 7 this year. But if not, so that we have to discuss longer. But it will the GILS and the auto fiber will be introduced into Ruby 3 anyway. Then GILS, and actually the GILS prototype is working in the hand of the Koichi, who is in charge of the GILS. But no one else verified his work, so that it's still kind of mystery. I don't think it will be introduced in the Ruby 7 this year.
I see, thank you. And so my second question is about the Ruby 3's type checking. And because from your talk, it seems like we will have a static type checking, right? But for the SOBAT, they would like to design a very reliable type checking system, so they also have a runtime type checking. Yeah, so I'm just curious about your opinion about the runtime type checking.
Runtime?
Yeah.
Theoretically, the static type checking detect all the type errors in the software, so that you don't have to worry about the runtime type errors. But in reality, so that we have our static type check will not be 100% accurate, so that we still have sometimes the runtime type errors. So that it's kind of the reality difference or something.
Okay, one last question.
Yeah.
Hi. I saw the recorded videos. There's a voting about what gens you install after you install immediately after you install Ruby. And I'm happy that bundler is already bundled gen in Ruby.
Yeah, bundle is bundle. Yes.
But the other one is PRY.
Uh-huh.
And I think this is very important because sometimes I need to debug with interrupt in the middle of my code. So is there any plan to edit PRY function or into IRB or something?
The IRB is improving, and we have introduced some part of the PRY into the IRB. Even after Ruby 3, the IRB is still being the canonical repo tool. But if you like PRY, of course you're free to use PRY. And as in his Shibata-san session, so that we are going to introduce about the improvement for the IRB, which is even better than the PRY in some aspect.